Insulation resistance testing is beneficial for new residential homes. It can identify potential safety hazards. High resistance indicates issues with the insulation such as moisture, damage, or loose connections. These issues can lead to electrical shocks or fires. It helps ensure code compliance. Most electrical codes require insulation resistance testing to ensure compliance with safety standards. It provides peace of mind. Knowing that the insulation is in good condition can give homeowners peace of mind about the safety and reliability of their electrical system. The time and profit implications of insulation resistance testing in new homes vary depending on the size and complexity of the home. However, it is generally considered a worthwhile investment for the following reasons. Firstly, it is quick and efficient. Testing can be done relatively quickly, typically taking less than an hour for a typical home. Secondly, it is low cost. The equipment and labor costs for testing are typically low, making it an affordable option. Thirdly, it has potential savings. Identifying and addressing insulation issues early can prevent more costly repairs down the road, such as electrical shocks, fires, or damaged appliances. It is recommended to perform insulation resistance testing in new residential homes during the following stages. Firstly, pre-drywall. Test before insulation is installed to ensure proper installation and minimize the risk of moisture damage. Secondly, final inspection. Test after the insulation is installed and connected to ensure proper wiring and connections. Insulation resistance testing is not a substitute for other safety measures such as ground fault circuit interrupters, arc fault circuit interrupters, and smoke detectors. Insulation resistance testing, often performed using a megameter, also known as a mega, is a crucial diagnostic procedure for evaluating the integrity of electrical insulation in residential electrical systems. The fundamental principle behind this testing is to apply a direct current voltage to the insulation and measure the resulting current flow. The insulation resistance is then calculated using Ohm's law, which is resistance equals voltage divided by current. A high resistance value indicates that the insulation is in good condition and effectively preventing current leakage, while a low resistance value suggests insulation degradation, potentially caused by moisture, contamination, physical damage, or aging. In new residential homes, insulation resistance testing offers several key benefits. Firstly, it helps identify potential safety hazards that may not be apparent during a visual inspection. For example, compromised insulation can lead to electrical shocks, fires, or equipment malfunction. By detecting these issues early, corrective actions can be taken to prevent accidents and ensure the safety of occupants. Secondly, insulation resistance testing ensures compliance with electrical codes and standards. Many jurisdictions require insulation testing as part of the electrical inspection process for new construction. By performing these tests, contractors and homeowners can demonstrate that the electrical system meets the required safety standards and obtain necessary permits and approvals. Thirdly, insulation resistance testing provides peace of mind for homeowners. Knowing that the electrical system has been thoroughly tested and meets safety standards can alleviate concerns about potential electrical hazards. This can be especially important for families with young children or elderly individuals who may be more vulnerable to electrical accidents. From a time versus profit standpoint, insulation resistance testing is generally considered a worthwhile investment in new residential homes. While the testing process does require some time and expense, the potential benefits in terms of safety, code compliance, and reduced risk of future problems outweigh the costs. The testing procedure is relatively quick and straightforward, typically taking less than an hour for a standard-sized home. The cost of the testing equipment, which is the megameter, and the labor involved are relatively low compared to the overall cost of constructing a new home. Furthermore, identifying and addressing insulation issues early can prevent more costly repairs down the road. For example, a small insulation defect can lead to moisture damage, which can cause wood rot, mold growth, and structural damage. Addressing these issues early can prevent the need for extensive repairs and replacements, saving homeowners significant amounts of money in the long run. To maximize the benefits of insulation resistance testing in new residential homes, it is recommended to perform testing at two key stages. Firstly, pre-drywall stage. This involves testing the wiring and insulation before the drywall is installed. This allows for easy access to the wiring and makes it easier to identify and repair any defects. It also ensures that the insulation is installed properly and meets the required standards. Secondly, final inspection stage. This involves testing the entire electrical system after the drywall is installed and all electrical connections are made. This ensures that the entire system is functioning properly and that there are no hidden defects. When performing insulation resistance testing, it is important to follow proper safety procedures and use calibrated equipment. The megometer should be properly grounded to prevent electrical shocks. The testing voltage should be appropriate for the voltage rating of the insulation being tested. The test results should be carefully documented and interpreted by a qualified electrician. While insulation resistance testing is a valuable tool for assessing the condition of electrical insulation, it is important to know that it is not a substitute for other safety measures. Ground fault circuit interrupters, arc fault circuit interrupters, and smoke detectors are essential safety devices that should be installed in all new residential homes. These devices provide protection against electrical shocks, fires, and other hazards that may not be detected by insulation resistance testing. In summary, insulation resistance testing is a beneficial practice for new residential homes. It helps identify potential safety hazards, ensures code compliance, provides peace of mind, and can save money in the long run. It is recommended to perform testing at the pre-drywall stage and the final inspection stage. However, it is important to remember that insulation resistance testing is not a substitute for other safety measures. By implementing a comprehensive approach to electrical safety, homeowners can ensure the safety and reliability of their electrical systems. Now, let's delve deeper into the specifics of insulation resistance testing using a megometer, also known as a megger. A megometer is a specialized instrument designed to measure high resistance values, typically in a megohm range, which are characteristic of good electrical insulation. These devices generate a high direct current voltage, ranging from 500 volts to 5000 volts or more, depending on the specific application and the voltage rating of the insulation being tested. The high voltage is applied across the insulation, and the resulting current flow is measured. Insulation resistance is then calculated using Ohm's law. There are two primary types of megometers. Firstly, analog megometers. These devices use a moving coil meter to display the resistance value. The meter is calibrated in megohms and provides a direct reading of the insulation resistance. Analog megometers are typically less expensive than digital megometers, but they may be less accurate and more difficult to read. Secondly, digital megometers. These devices use an electronic display to show the resistance value. Digital megometers offer higher accuracy, easier readability, and additional features such as data logging and automatic ranging. They are generally more expensive than analog megometers. When selecting a megometer for insulation resistance testing in residential applications, it is important to consider the following factors. Firstly, voltage range. The megometer should have a voltage range that is appropriate for the voltage rating of the insulation being tested. For most residential applications, a megometer with a voltage range of 500 volts to 1000 volts is sufficient. Secondly, resistance range. The megometer should have a resistance range that is appropriate for measuring the insulation resistance of the electrical system. A megometer with a resistance range of 0 to 2000 megohms is typically adequate for residential applications. Thirdly, accuracy. The megometer should have a high degree of accuracy to ensure reliable test results. Digital megometers generally offer better accuracy than analog megometers. Fourthly, features. Some megometers offer additional features such as data logging, automatic ranging, and temperature compensation. These features can be helpful for analyzing test results and identifying trends. Before performing insulation resistance testing, it is essential to follow proper safety procedures to prevent electrical shocks and other hazards. Firstly, disconnect the power. Always disconnect the power to the circuit being tested before performing insulation resistance testing. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, verify the absence of voltage. Use a voltage tester to verify that there is no voltage present in the circuit before proceeding with the testing. This is a crucial step to ensure that the circuit is energized and safe to work on. Thirdly, ground the megometer. Connect the ground lead of the megometer to a suitable ground point, such as a metal water pipe or a grounding electrode. This helps to prevent electrical shocks by providing a low resistance path for fault currents. Fourthly, wear personal protective equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses, to protect yourself from electrical hazards. Now, let's discuss the procedure for performing insulation resistance testing. Firstly, prepare the circuit. Disconnect all loads from the circuit being tested, such as appliances, lights, and electronic devices. This will prevent these loads from affecting the test results. Secondly, connect the megometer. Connect the test leads of the megometer to the conductors being tested. For example, to test the insulation resistance between a hot wire and ground, connect one test lead to the hot wire and the other test lead to a suitable ground point. Thirdly, apply the test voltage. Turn on the megometer and apply the test voltage for a specified period of time, typically 1 minute. This allows the insulation to become fully charged and provides a stable reading. Fourthly, record the resistance reading. After the specified time period, record the resistance reading displayed on the megometer. This is the insulation resistance value for the circuit being tested. Fifthly, interpret the results. Compare the resistance reading to the manufacturer's specifications or industry standards to determine whether the insulation is in good condition. A higher resistance value indicates good insulation, while a low resistance value suggests insulation degradation. When interpreting insulation resistance test results, it is important to consider several factors that can affect the readings. Firstly, temperature. The insulation resistance of most materials decreases with increasing temperature. Therefore, it is important to record the temperature of the insulation during the test and correct the readings if necessary. Secondly, humidity. High humidity can also lower the insulation resistance. It is important to avoid testing in humid conditions or to take appropriate measures to dehumidify the area being tested. Thirdly, surface contamination. Surface contamination such as dust, dirt, or moisture can create leakage paths that lower the insulation resistance. It is important to clean the surface of the insulation before testing to remove any contaminants. Fourthly, test voltage. The test voltage applied during the insulation resistance test can also affect the readings. Higher test voltages can stress the insulation and reveal weaknesses that may not be apparent at lower voltages. However, it is important to use the appropriate test voltage for the voltage rating of the insulation being tested. Now, let's discuss some common problems that can be identified through insulation resistance testing. Firstly, moisture. Moisture is one of the most common causes of insulation degradation. It can penetrate the insulation and create conductive paths that lower the insulation resistance. Secondly, contamination. Contamination, such as dust, dirt, oil, or chemicals, can also degrade insulation and create leakage paths. Thirdly, physical damage. Physical damage, such as cuts, abrasions, or punctures, can compromise the integrity of the insulation and lower its resistance. Fourthly, aging. Insulation materials degrade over time due to heat, oxidation, and other factors. This can lead to a gradual decrease in insulation resistance. Fifthly, improper installation. Improper installation of insulation, such as loose connections, damaged insulation, or incorrect wiring, can also lead to low insulation resistance. In addition to identifying insulation problems, insulation resistance testing can also be used to verify the effectiveness of repairs. After repairing or replacing damaged insulation, it is important to perform insulation resistance testing to ensure that the repairs have been properly made and that the insulation meets the required standards. In conclusion, insulation resistance testing is a valuable tool for assessing the condition of electrical insulation in residential electrical systems. By performing these tests regularly, homeowners and electricians can identify potential safety hazards, ensure code compliance, and prevent costly repairs. Remember to always follow proper safety procedures and use calibrated equipment when performing insulation resistance testing. Now let's explore some specific scenarios where insulation resistance testing proves particularly beneficial in new residential homes. Firstly, detecting damage during construction. During the construction process, wiring and insulation are susceptible to damage from various sources, such as tools, equipment, and weather. Insulation resistance testing performed before drywall installation can identify any such damage, allowing for timely repairs before the damage is concealed. This prevents future electrical problems and potential safety hazards. Secondly, verifying proper installation. Even with careful installation, errors can occur, such as loose connections, pinched wires, or improperly installed insulation. Insulation resistance testing can detect these errors, ensuring that the electrical system is installed correctly and meets safety standards. Thirdly, identifying moisture intrusion. Moisture is a common enemy of electrical insulation, as it can significantly reduce its resistance and lead to short circuits and ground faults. Insulation resistance testing can identify moisture intrusion in walls, ceilings, and other areas, allowing for prompt remediation to prevent further damage and potential hazards. Fourthly, assessing the quality of materials. Insulation resistance testing can be used to assess the quality of insulation materials used in the construction process. By testing samples of insulation, contractors can ensure that the materials meet the required specifications and provide adequate protection against electrical hazards. Fifthly, pre-warranty inspection. Before handing over a new home to its owners, performing a comprehensive insulation resistance test can serve as a pre-warranty inspection. This provides assurance to the homeowners that the electrical system is in good condition and minimizes the likelihood of future warranty claims related to electrical issues. Moreover, consider the long-term benefits of regular insulation resistance testing. Firstly, preventing electrical fires. Damaged or degraded insulation can lead to short circuits and ground faults, which are common causes of electrical fires. Regular insulation resistance testing can identify these issues before they escalate into fires, protecting the home and its occupants. Secondly, reducing energy consumption. Degraded insulation can increase energy consumption by allowing electricity to leak to ground. This wasted energy translates to higher utility bills. Insulation resistance testing can identify areas where insulation is failing, allowing for targeted repairs that can reduce energy consumption and lower utility costs. Thirdly, extending the lifespan of electrical equipment. Electrical equipment, such as appliances and electronics, can be damaged by voltage fluctuations and surges caused by insulation problems. Maintaining good insulation can protect this equipment from damage and extend its lifespan. Fourthly, improving safety. Electrical safety is paramount in any home. Regular insulation resistance testing can identify potential electrical hazards such as shocks and electrocution risks, allowing for prompt corrective actions to ensure the safety of the home's occupants. Fifthly, complying with insurance requirements. Some insurance companies may require regular insulation resistance testing as a condition of coverage. Performing these tests can help homeowners comply with insurance requirements and maintain their coverage. Now let's address some common misconceptions about insulation resistance testing. Firstly, it is only necessary in old homes. While it is true that insulation degrades over time, it is also important to test insulation in new homes to identify any damage or installation errors that may have occurred during construction. Secondly, it is too expensive. The cost of insulation resistance testing is relatively low compared to the potential costs of electrical fires, repairs, and injuries. Thirdly, it is too time-consuming. Insulation resistance testing can be performed relatively quickly, typically taking less than an hour for a standard-sized home. Fourthly, it is only for professionals. While it is recommended to have a qualified electrician perform insulation resistance testing, homeowners can also learn to perform basic tests using a simple megometer. Fifthly, it is a substitute for other safety measures. Insulation resistance testing is a valuable tool, but it is not a substitute for other safety measures such as ground fault circuit interrupters, arc fault circuit interrupters, and smoke detectors. In summary, insulation resistance testing is a valuable investment for new residential homes. It offers numerous benefits, including improved safety, reduced energy consumption, extended equipment lifespan, and compliance with insurance requirements. By performing regular insulation resistance testing and addressing any identified issues promptly, homeowners can ensure the safety, reliability, and efficiency of their electrical systems.